Hi guys, I'm Darren, and in this video I'm going to be taking my first look at ExpressLRS. So if you've seen a few of my posts in like Facebook groups and stuff like that, you might think that this is a bit of a strange thing for me to look at. I've openly put up that I have a few issues with the system, and I'll go over those just so that you guys have all the information. But it's still, I'm not going to give it final judgment until I've actually had a look, and also I need to use it for testing something. So I figured let's actually just get one and have a look. Before we get into actually looking at the modules, I'm sure everyone's heard the hype, because let's face it, there's been a lot of hype. And to be honest, that's one of the big things that puts me off. I don't really have brand or technology loyalty. I'm quite happy to use whatever works and give props to whatever works. So I use TBS Crossfire, I use R9, but at the same time, if TBS come out with a new product, I'm not going to be like, oh yeah, this is the best product in the world, until I've actually got around to using it. So yeah, it's TBS sort of had a history of having quite a fanboy following, where someone put up a problem, for example, I'm having X issue with R9, how can I solve this specific issue, which would usually be a really simple thing to solve. But you'd always get posts saying, use TBS, and it just really and now that sort of disappeared, but what's taken over is use ELRS. So it's just this typical fanboy nonsense rather than actually helping with issues and just, you know, giving props for what it's good at. Now the first thing is, yeah, it does seem to have really good range. It does have low latency, and it does have really good frame consistency. I'm not arguing that at all. So as far as the link goes, it looks good and it seems to work good. So to get that latency and consistency, they've had to mess about with the frequencies and also the actual data that's sent to. So you're limited on what you can send channel wise. You only have 4 full resolution channels, and then you can have, depending on how you set it up, you can have just 3-way switches on the rest of it, or a 2-way switch on channel 5, which you should always use for arming, or you can use what they call hybrid 8, which has, this is one thing I need to test. It's, you can set up channels 6 to 11 as either a 3-way switch, or a 2-way switch, a 3-way switch, or a 6-way switch. But in the frequency charts, there are actually 7 positions, so possibly you could put 7 positions on there. I need to test that. That's one of the reasons I've got this. And then on channel 12, it's a 16 channel. So if you're flying really basic stuff, and there's no problem. So this is why I think the popularity has gone through the roof, is because quad pilots have jumped on it. All they have at the end of the day is 4 channels for the gimbals and then a couple of switches. So there's really no need for anything. But as fixed wing pilots, when we have things like pan and tilt, we could want scalable flaps or crow braking, stuff like that. You just can't do that with the LRS, with what they've currently got available. But in fairness, on their website, it does say that they're potentially going to look into a more sort of long range solution, so you can have either more full resolution channels, or at least more options, with the trade-off that there's high latency. But in all honesty, latency, unless you're racing something, latency is a bit of a sales pitch, to be honest. So long as it's acceptable, which pretty much all the links out there that you can get now are, they're all acceptable, then there's no problem at all, unless you do need that instant reaction. And even then, it's more going to be the consistency that is better than the latency. So having the consistency there is the more important thing. But anyway, I'm sort of digressing. So to get that faster or lower latency, they have done away with channel features, and they also have been a bit naughty with frequencies or the radio system. So technically it's not really legal to use anywhere. People were saying, oh, it's a grey area, but no, it's, even on their website, they say in the EU, they are supporting the 800 megahertz frequencies, but they're not LBT compliant. So not LBT compliant means not legal. Everywhere else in the world, and for other bands, they aren't sticking to necessarily all the right frequencies. So you could potentially be interfering with something that you shouldn't be, which of course is not going to be good for the hobby in general. So the best thing to do if you do want to try ELRS is probably use the 2.4 stuff, because in that region you're a lot safer basically. So that's what I've got here is 2.4. So it's going to be interfering with Wi-Fi and crap like that. That doesn't really matter if it does interfere. As I say, in the EU it should be frequency safe, but it doesn't do listen before talk. So if it does trample over someone else's signal, that's why it's not listening first. The other thing that I'm not overly keen on is they're using the crossfire protocol, but they've not actually licensed it from TBS, which means they've reverse engineered it. It's basically a clone. So while it seems like the hobbyists in general are more accepting of clones, or they don't care either way, like they're quite happy to use Jumper, which are clone transmitters. They're now quite happy to use ELRS, which is using a cloned protocol. Basically, the answer is it's cheap, it works, why should I care? The reason is TBS developed the crossfire protocol, so they've invested time and money. If people just clone it and people buy the clone, what's the incentive to TBS to go and take it to the next level? What's the incentive to improve crossfire? They've put all the time and work in. The same really goes for FreeSky with like the X10, the Horus X10, which was cloned by Jumper, and the Radio Master receivers are clones of X8Rs in some instances. So where's the incentive for them to progress further if they put all this time, money and effort in and someone else just basically steals it? So that's basically my gripes with the LRS. But anyway, we're going to take a look at it. This is the HappyModel 2.4 system, so we're just going to have a quick look at the board and the receiver and have a little chat. Okay, so let's take a look at the transmitter module first. I've got the full-size JR Bay version. They do also have a light JR Bay version, but I'll probably be using this in my Horus, so I've gone for the full size. So it comes with a case, which is not actually 3D printed. It's injection molded. It's decent enough quality. It's quite a soft rubber or soft plastic, and there's mounting points for a fan and the antenna in the top. So yeah, pretty simple, not much really to talk about there. You get the 2.4 transmitter antenna, and you can see the advantage of 2.4 in the size of this antenna. Now, how well tuned this is, who knows? Will it be as good as the stuff you get with Tracer or Ghost? So you get this link cable, which goes from the main board to obviously the case, and that's where you screw your antenna into. So it's SMA, and it's a little bit flimsy cable. It would have been nice if I had some sort of RG316 on there, a bit beefier cable. But there you go. It's only, I think I paid £35 for this module and the receiver. So it's about a £25 module. So they're obviously cutting corners on some places. And you actually get the screws. So this, I think, is a slightly newer module, because I have checked out some other people's stuff. So I saw Oscar Lang's webpage, and some of the criticisms that he had about this seem to have been sorted out. So this is the actual module itself, and it's based around an ESP32, and I believe it has another ESP chip in there as well. So it's actually got multiple chips on there to do the work. There's a micro USB connection. This is obviously the header for the JR Bay, so the pins just slide in the bottom there. And they've added a couple of nice things which were missing from what Oscar was reviewing, which is a fan header. So you can just plug a fan into it. You don't have to sort of piggyback off of other components anymore. And there's also an LED header. The only issue I found is I can't actually find a fan with this actual connector on it. So it'd have been nice if I had supplied in the bag just like a blank connector that you could just solder some wires onto. And the same with the LED. I mean, the fan is just going to be a positive and negative. That's going to be easy enough to work out. But the LED, it's got 3 pins. So potentially it could be a color changing LED or an RGB LED or even a data-driven LED. We don't know. There's no actual specs for this. I've looked around the internet, but can't find anything on that. They also don't seem to sell the LED on their website. And also, there's no space in here to mount an LED. You just have to probably put it somewhere, poke it through a hole or whatever. It'd be actually quite nice if it just shines through the grills. But there you go. So there's a few extra mounting points. We have some buttons which hopefully you don't actually need. There's a reset button there. I believe that's a reset there. So you basically have a button per ESP configuration. And then we have finally the IPEX1 UFL connector here. So there are some jumpers, and I think that's to relate to where the USB connects to. So it's set up to be connected to the ESP32. But the only real reason to use the USB is for setting up the firmware. If you want to do it via cable, it has got Wi-Fi, so you can do it over Wi-Fi as well. To do it over Wi-Fi, you need a sort of Lua script on your transmitter to access all this sort of stuff. But it might be easier, seeing as there's no actual way of getting at the USB without taking the case apart. So I think that's where you'll see the differences in, you know, sort of more expensive, better engineered systems. So for example, on Crossfire, the USB is just accessible at the side or in the front, depending on which module you have. R9 is done straight through the transmitter, so it's really nice and simple. And that was one of the things I've noticed with ELRS, is it is a little bit more involved to actually get the updates done compared to the other systems. But still, it's, if you're used to a configurator, so if you're used to iNav, BetaFlight, if you BL Heli, it's really not overly difficult. But we'll take a look at that in a minute. So next up we have a receiver. There are a couple of different models to go for, but I actually went for the one with an antenna rather than a little like block thing. Basically, if you have a look at the pictures, you'll see what I mean. But this one here actually comes with 2 antennas, which is quite cool. And again, this thing costs, it was about £10, so very cheap. And instantly we can see why 2.4 is nice, as the size of that thing is tiny. I mean, I've not used Tracer or Ghost, so I can't really compare it, but that is absolutely tiny. It must be about, what, 15 mil square? Or even smaller than that, 10 mil. About 10 millimeters square. So that is absolutely fantastic that you can fit all that onto there. So there's not really a much to say about these. Obviously you can get a version that's got a little tower, and like the actual antenna is wrapped around the square of the tower. But where I'm flying fixed wing, that would be stuck inside somewhere. It would probably penetrate the foam, but I'd rather have something that's going to give a better signal, and a standard sort of T antenna will do that. And the different lengths of cable or the lead to the antenna is actually really nice. So depending on what you're putting it in, I mean, that might be fine on a quad, but something like that will probably be better on a plane. Having said that, if you're mounting it in a wing, you could have that really nice and close, because that's going to weigh absolutely nothing. It's like it's a centimeter square pretty much. But yeah, it gives you lots of options. You just have the 4 pins here, and that'll be ground. Well, I don't know the order, but it will be ground, power, RX and TX for the Crossfire protocol. And there is another little pin there, which is not labeled, so I don't actually know what it's for. Is that an LED? Yeah, so that could be an LED right there, for just indicating bind, I guess. But there's no physical buttons or anything like that. And one of the reasons for that is you can set up on ELRS a like a passcode. I can't remember what they call it. We'll have a look at the configurator in a sec. But basically, if you have the same passcode, which you obviously want unique to yourself, on the transmitter and the receiver, they will just automatically bind, which is really cool. If not, you can bind it using a different method if you don't want to have a passcode. But what we'll do is we'll have a look at the configurator and we'll do an update on this. Okay, so this is where we can get everything. It's got all the information, all the documentation, everything is now on this website. It used to be on the GitHub. Sorry, that should just be expresslrs.org. But yeah, you can get everything you need to on here now. So it's just expresslrs.org. I'll put a link in the description. It's got quick start guides, information about the hardware, software, all the useful information you'll find on a website. A dark mode. Interesting. Okay, so all we'd need to do is download the configurator, which is actually taking you to GitHub. I've actually got version 1.0.7, so I will do an update. But what I'm going to do first is just have a look to see the update process. So in configurator, if there is an update, it will say update is available. If we click on that, it just takes you to GitHub. So we can just follow the same process. So all we're going to do is scroll down the bottom. Of course, you've got release notes where you should, change logs. And what we need to do is download the actual configurator for us. So I'm on Windows, so I'm just going to use this ELRS setup. So let's save it in the desktop. So to see which version you need, they actually list it up here. So if you're on Windows 8 or Windows 10, you just want this setup that I've clicked on. If you're using macOS, you want the DMG file. And if you're using Ubuntu or a different Linux implementation, there are different download files for you there. So just download it. Once it's finished, we can close this down. So they do have a quick start guide on the website, which is actually quite good. I went through that. And just to mention, or just to clarify what I was going on about earlier with the frequencies, this is actually where they admit it on their website. So you can see it's 868 is frequency compliant, but not LBT compliant. Every other band is near compliant, so it's not compliant. So the only reason I'm bringing that up is so you have all the information. Whether you think that's acceptable or not is down to you. I'm not here to sort of preach or anything like that. Let's face it, most of us fly over 25 milliwatts on 5.8 VTXs. So, but yeah, it's down to you. I'm just giving you the information. Right, let's get rid of this website. Let's close down the old configurator. And what you'll get on your desktop is this nice installation file. If you get a message like this on your computer, there's a little link thing that says more information. If you press that, you'll get this run anyway box. So just click run anyway, because we know that this is safe. And then you'll get the standard install or Windows install application. So just click that. You might get another confirmation box. Just click yes. Windows is a bit too much of a pain. Then you can choose where you want to install it. So I'm just installing over the one I installed originally. So if you want to choose a different location, choose the location you want. But then it will install the configurator. When that's done, we'll come back. Well, that took longer than expected. There was issues. For some reason, it was freezing when I tried the update. I ended up having to uninstall the older version of the ELRS configurator manually and then install this newer update. It still did take a bit of time, so it may have just been that it was slow in the uninstall, but the progress bar was just stopped. So I thought, yeah, sod it. Let's just get it working. So if you have any problems, just uninstall manually, then install the new version, and it will work. It does still just take a bit of time. So once it's finished installing, you will get this screen where you can choose to run or not. Might as well run. So eventually this is what you get to, and this is the ELRS configurator. There's some stuff on there like a serial monitor and logs, so we're not going to go into that. There's more stuff which is really for developers. All we're really interested in as a consumer or a pilot is the official releases area. So I'd leave show pre-releases off because that would be beta products, so not necessarily tested to the full extent. The latest version is already shown in the box. You see on the latest version. Next up, we need to select our target. So because I'm flashing the receiver module, which I have here, we need to choose the category. So we have our HappyModel 2.4. Likewise, you've got the other frequencies there, and other different types of transmitters or receivers. But anyway, we're going HappyModel 2.4 gigahertz because that's what we're using. And then we need to choose the exact model. So we have the transmitter and the slim transmitter, and then we have the EP and PP type receivers. So we're going to go for the ES24TX, which, if you forget which one you have, if you look just below the JR bay pins, you can see screen printed, it says the ES24TX. So you know which module you're using. It's actually got the V2 on there for the hardware version as well. So we select our correct TX, and then we have the flashing mode. So we can do it via UART, which means we'll be using our USB cable basically, or we can do it via Wi-Fi. But the Lua script is here. While we're talking about OpenTX and Lua scripts, you will need to be using one of the latest versions of OpenTX to use this. So the minimum version was 2.3.13, and I think we're now on 2.3.14, and that's what I've put on my Horus to test this out basically. I'm going to be using the USB link, so I'm leaving it on UART. And then what we have are some device options. So most of these are basically what are on their standard. I've only enabled a couple of things. Regulatory domain, I've not touched that. Inverted UART, again, I've not touched that. Unless you know that you need to use an uninverted UART, you should just leave it as is. If you hover over these question marks, it is actually really useful. So this part here, the binding phrase, is what I sort of alluded to earlier. If you fill this in and then you have the same binding phrase on the transmitter and on the receiver, when you power them up, they'll instantly bind with each other. Like I said, this should be unique to you. If someone else has the binding phrase, they can just bind straight to your stuff. So you don't really want to share it with anyone. You want something pretty unique. And if you don't want to use it, you can actually just get rid of it and turn the binding phrase off, in which case you'll have to use a different method. And I did find out what that tiny little square was. That when you put it to ground is actually the binding switch. So, which is a bit tiny. So again, that would be a right pain in the arse. And having used systems with over-the-air stuff now, like Crossfire and the R9 Access stuff, it's just so much nicer just to switch something on and it binds. So I'd use the binding phrase, but obviously make sure your phrase is unique. OpenTX sync, that's on by default. Again, there's no reason to really turn these things off unless you've researched them and decided you don't want them. So hybrid switches 8 I turned on, and that's the option that gives you extra resolution in your switches. So as I mentioned, on the standard with this turned off, you can only have 2 or 3 position switches on channels 6 to 12, whereas the hybrid 8 has 2, 3 or 6 position switches on 6 to 11, and then 16 position on channel 12. So that's what that option does. And then enable telemetry. Why wouldn't you? Well, if you're a quad racer, you don't need it, but anyone that flies anything like long range or just FPV in general with fixed wing, telemetry is very useful. Okay, and finally down the bottom we have 2 options. We have build and flash. Now the build, I believe, is for if you're using a Wi-Fi installation method, and build and flash we can use with device. So let's plug in with the USB. So now that's connected. So what I'm going to do is choose COM6, which is what that's connected to, and now I can click build and flash. It'll build the firmware and flash it. So what I'm going to do is come back when this process is complete, because it's quite an intensive process on my computer. So it may be that the video gets really choppy. So yeah, that's why. There we go. I did actually do a build of the firmware before running that the first time. So maybe it's pre-compiled some stuff, which is why that one was a bit quicker and didn't mess with my computer too much. But there we go, it's flashed it to the unit. So what we can do is unplug it. It's all up to date. So there's not really much to show on the configurator. Obviously, if you're updating receivers, that's a slightly different process. And I'll again show that in another video once I've got all this set up. So I'm just going to head back to the desk and then we can have a final look, because I did actually find something out while I was waiting for the installation to happen. Actually, before going to the desk, again, just going over the elrs.org website, it is actually really useful. The information for the receivers themselves, I did look on HappyModel but couldn't find pinouts or anything, but they are actually on the ELRS website and it's easy enough to find. But it gives you, so these are the receivers. I have this receiver here, the EP1, and the EP2 and PP are the ones that I mentioned with that little tower antenna. So they don't have a UFL connector on, they just have this tower antenna instead. But yeah, so there's the bridge to boot if you want to use the binding, and we have ground, VCC, TX and RX. So it's nice simple wiring. If you're used to wiring Crossfire, it's identical. And of course on the flight controller, ground and VCC will go to ground and 5 volts. TX will go to the UART's RX and the RX will go to the TX. This is standard UART wiring, so that's really nice and straightforward. Okay, so before wrapping this up, like I mentioned, while the installation was taking forever, I thought I would try and put the antenna in here. And it seemed like it was a really bad fit. But actually, one side of the thread has got a flat on it. So it's actually really nice. When you look in the hole, there's a flat edge. Line the flat to the flat, it'll push through, and then it will allow you to tighten it with no issues whatsoever. So we're basically done. All we need to do is connect up this UFL. There we go. Now, I believe if you want to use it at the highest power level, you do need to get the fan. I looked again on the HappyModel site. There is a fan on the HappyModel site, not an LED, but I can't find anywhere to buy the fan at the moment. So it's probably something that's coming soon. But yeah, if you want to run it at the highest power level, you will need to install a fan. If you step it down one level, then it should be fine without it. So that will go in there. There's a couple of screws. Right, so we have a couple of different types of screws. So these flat ones, I'm assuming are going to be the ones for the PDB, because that would make the most sense. And then just standard ones for the back of the case. Right, this is a PH0 screwdriver. Okay, so that is the circuit board in. And finally, we just need to coil that antenna cable round, line that up and screw it up. So yeah, I think these are going to be the standard sort of screws rather than the pan heads. Yeah, there we go. So you basically got one spare screw of each type. Yeah, this case, it doesn't give you confidence when you tighten the screws up. It just feels like they're going to potentially strip the threads, which obviously you don't want. But that is basically it. I do like the size of these little antennas. And of course, where it's SMA and it's just 2.4, it means you can get something like a shapeshifter or like a Moxon, so you can really improve the antenna. And finally, let's just see how well this thing fits in. Oh, it's very snug. Yeah, that is really tight. So sizing could have actually been better. I'm sure that's in. But yeah, that was really quite snug. which means getting it out could be a bit of a pain. Let's take the antenna off so I don't pull it off. Oh yeah, that's tight. So yeah, really not the best case, but as I said, it was 25 quid for the whole lot. So there you go. That's going to be my introduction, I think. We will explore more in a future video. We'll do the Wi-Fi update. We'll show how to get the Lua script on the transmitter. We'll do the update. We'll also look at the receiver updates and also having them bind. But for now, I hope you enjoyed the video. I hope, again, I'm not trying to say yes or no to using this. That's purely your choice. I just want to get all the information out there so that you can make your own informed decisions. But hopefully you found it useful. If you did, don't forget to give it a thumbs up. Or if you absolutely love ELRS and are a complete fanboy, you can give it a thumbs down if you want. I don't care. But anyway, fly your models like you stole them. Have a great time. I'll see you on the next one.